Okay, so we are left with some high level, scenarios with HDFS, I think. You must have not tried, some of you must have tried, but I think the ones who are facing issues with the cluster, they might have not tried this. So just do it once everything is fine on the cluster, okay? Okay, so yeah, we are left with safe mode and we have to add two more data nodes to the cluster, and I have to explain you about high availability. Okay, okay, so quickly a recap. So last time we had done an HA, and now we have an active and a standby name node. You guys can try out, stopping the active name node, and you will see that the standby will quickly become active after that. So that's the beauty of HA, that your cluster is always available because now you have two different data nodes, but one of them will always be active, the other one will be in standby. Okay, so let's try to understand few services all that were added as part of the HA. Okay, so if you remember when we were doing the steps of HA, there the first step it asked us was the name service thing, right? So it asked us to create a name service for the cluster, and I think I gave you this example wherein it become HDFS. Okay, I gave you an example wherein we were doing HDFS, DFS, LS like this, right? And this is the name service which I had given when I was doing the HA in my cluster, right? Now, what happens is earlier we were doing the same command by passing the name node IP address and the name node port, something like this, right? But this was good enough when we didn't had an HA or a high available environment, and we only had one single name node which was acting as an active one, while the other one was a secondary name node, right? So although this would also work fine if we have somehow, so right now we try to hit the standby name node. You can see it says read is not supported in state standby, because I think we were hitting the 172 176. This is our standby name node. But if we want to hit the active main node, every time we will have to come to the Cloudera manager and check which one is active. So right now 69 is active. So although this command will also work, because this is now the active name node we are trying to interact with, but let's say at an instant, now this one becomes active and this becomes standby. So our programmers who are writing code for trying to read from the HDFS, they might have to shift in all of their code. They have to change this IP address from this to this, right? This is where name service comes into importance, because name service, which is this value, will always point to the active name node in the cluster. Okay, so even if when I just make switch off this host and now this standby server becomes active, the Hadoop B9 will still point to the active name node only. So it will change its alias at the backend to the active name node every time. That's why this property or this link can be shared with your programmers, developers, and there would be no need even when the active name node changes within the cluster. This is where name service is good for understanding. Let me just paste this so that you can refer it from the logs. Okay, so just try to check it in your clusters also. Try running a simple ls command just like this on your name nodes, and then try with the Hadoop B9, or sorry, whatever name service you have given, and then just try to stop the active name node. Like you can either stop it or you can restart it, so that what will happen is the other one will become active now then, and just try the same command of B9 again and you will still see that everything works fine, because this name service, it always points to the current active name node in the cluster. Okay, the other thing is a journal node which is added, which you can see. So we added 3 journal nodes in the cluster, right? Now journal node, it's, I think I explained as part of this architecture also. So earlier what was happening was each name node was so let's say if we talk about the old non-HA environment, in the name node location there was a directory slash DFS slash NN, and in the secondary name node there was another directory slash DFS slash JNN, sorry, SNN, and in these two directories they stored the FS image and the edits file. These two files I told you, right? These are the main files which name node refers to while storing the complete information about the cluster. But I also told you that if name node goes down and somehow it is not able to recover, so we will get those files from the DFS SNN. But if you remember, there was some way it was out of sync. This location had files which were older, while the newer files were still on the active name nodes location, right? So to avoid this situation in HA environments, now what happens is the shared the FS image and the edits are placed on a shared location on a particular service called journal node. Okay, so on each journal node, this is the directory which we mentioned while we were creating the HA environment. Okay, so on each of the journal nodes, you can find the FS image So let's just try and see it here, if what we see in that location. DFS JNN. Okay, you can see the name service Hadoop V9 in the current, right? So you can see there is edits logs, and I think, okay, it only stores the edits, I think, while the FS image is still on the name node location. So if I take this with the name node location, which is and yeah, so you can see edits are present here while the FS image is still on the name node locations. Okay, so what is happening is the current edits file, this is being shared on all the nodes where we have installed the journal node service. And since both of them are in sync, so the name node active and the standby both will have the same FS image. Now it's not the same scenario with the secondary name node, because both of them needs the current information about the cluster, so that if this becomes standby and this become active, then it can take ahead from the same place where the active one was operating. So FS image both will have the same thing, but the edits file, they will be present on the three journal nodes that you installed. So it's acting like a common place. It is the service used to store the edits information about the cluster at a common storage, from where both the name nodes can refer that. Okay, so both of the name nodes will talk to the journal node whenever it comes to getting the current edits file within the cluster. Okay, now another service apart from these we see is these two, failover controller. So as the name suggests, failover controller, it's controlling the two name nodes, and it's actually monitoring the failover scenarios of the two name nodes. So what will happen is, when we will, so let's say you can see both of these controller are actually present on the name node host 176 and 69. 176 and 69. So these two services are present on the name nodes, and they are continuously monitoring whether any of the nodes goes down. So if I just stop this server now, what will happen is the failover controller of this server, this will detect that name node has gone down, and it will refer that information to the zookeeper. Now there is a small role, although there is a small role of zookeeper service here. So this is continuously monitoring the state of each name node within the cluster, and as soon as the name node goes down, the same is reported to the zookeeper. So when you will actually check the name of the service on the server, no, you will see that its actual name is ZK failover controller, which means zookeeper failover controller. Let me show you. So this is one of my data nodes, right? Let me check the process. PS command is to check all the processes in the cluster. I think we discussed that earlier also. So ps-ef, and if you grep zkf, let's grab this. So you can see it's a DFS, or you can say a distributed file system, ZK failover controller. This is the actual name of this service. So it's continuously monitoring the state of the name node on which it is running, or you can say each name node or on which it is running. And as soon as the name node goes down, the same is reported to the zookeeper. So it reports this information to the zookeeper. Now you will say, why zookeeper? Because zookeeper, it here stores the state active of the name nodes. So the zookeeper is actually storing the state of the active name node within the cluster, and when that active name node will go down, this ZKFC will tell that zookeeper, okay, the earlier active one has gone down, now change the state to the other one, which is the current standby. Okay, so as soon as it happens, the other name node will take its place and become active. So this state will be changed to the other name node within the zookeeper. Okay, just for making this concept clear, let me show you a demo. Okay, first of all, I'll show you the demo. So let's say now I stop or I restart this active name node. Restart means, okay, let's stop it first and then we will start it. So as soon as I have stopped, now the failover controller, which is this on the 69, now it will quickly detect, okay, this one has gone down, although it's still appearing active, but it will take some time, and after that you will see this will report information to the zookeeper service. The zookeeper will change the state of the current active from this name node to this name node in some while. So in some while, if I just refresh it, it is still appearing active somehow. Might take some time. Now you can see as soon as it reports not running, the other one, which was 176, it has taken its place and become active. Okay, the other one is now active. How does this state change happen? It happened only because of these services failover controller. Okay, so let me just start it again. Now when I start the previous active name node, it will again, so failover controller will detect that, okay, this name node has started. It will contact zookeeper to check whether this currently started name node is active one or a standby one. So when this failover controller of 69 contacts the zookeeper now, the zookeeper will say, okay, the 176 is currently active, so you can make this as a standby, and it will make, and this name node will then come up as a standby name node. Let me start it.
Hey, this
Mm-hmm.
is Tasnim. On HA service, like if a split brain scenario happens, so like how do we create fencing?
See, fencing and everything is not required when you are working uh, with this environment. Okay, when you're working with a Cloudera manager, what used to happen when you manually used to create the HA, right? In that case, we used to specify fencing and other stuff. Now, what happens is everything is being taken care by the Cloudera manager. Although fencing is also present, if you just check fencing, it's the current method is shown as a shell. You have two different kind of fencing also apart from this, you know. But see what happens. Split brain scenario is something else. Okay, you explain me what is split brain scenario.
Oh, I can't tell you properly, but as much as I understand, is like where a cluster gets divided into smaller cluster. So like each one of believing like that is the only active cluster.
Yeah, kind of. So kind of you can say. So what happens in split brain scenarios is, uh, you don't have enough. The cluster doesn't have enough information to be sure which of the information is correct and which is not correct. And in that case anything can happen. So either the name node get confused, or even the journal nodes might get confused, which information, which edits to be stored and stuff like that. And mostly this happens because of the either zookeeper or the journal node. So that's why it's always recommended to have either three or something in the odd number of journal nodes in the cluster, because uh, you know you can think of it as a, let's say, in an election scenario. Zookeeper is also having that kind of an election scenario, just like, and journal nodes also have that stuff. So what happens in election is the one who gets the maximum votes wins, right? But if let's say there are even number of journal node and even number of zookeeper, and some equal number reports, selects one scenario and the other equal number. So let's say if there are four journal nodes, two of them uh, are on one side and two of them are on other side. So there will be no proper judgment coming out of that situations, right? That's why it's always told to have odd number, three or more number. But when you say if you want to select more, you should have odd numbers of journal node or odd number of zookeeper to prevent this split brain scenarios. Okay, so a very high level understanding is, what happens is there is kind of an election between the journal nodes and the zookeeper, and to avoid a split brain or a equal distribution scenario, we generally have an odd number of these services, so that you can ultimately come to a judgment once the election succeeds. Okay, so fencing is not, uh, it's not that much related to how you have done HA or how you are dealing with it, because all of this will be taken care by the Cloudera manager itself. But the questions which you should understand here is, to avoid such a scenario of split brain, you should have odd numbers, and that also greater than three. Now, what happens is, let's say you are having two journal nodes. Okay, first of all, you cannot avoid split brain scenario, because if one is saying something else, another one is saying something else, you ultimately are not deciding the correct situation out of it, or you're not coming out of a consensus because of that. So you should have at least three or more. Even one wouldn't work, because if let's say if you have only one journal node, and if that service goes down, okay, you won't have other journal nodes within the cluster to respond to such a scenario. Okay, so now you can see, as soon as I restarted the other name node, it has come in the standby state. Okay, so this is one scenario I wanted to show. The other one is, one second. Okay, now let's say what happens is these two services are down. Now I'm going to show you the scenario of split brain. Okay, you will explain it much better. So now I have stopped the failover controllers of both the name nodes. Okay, now what will happen if I stop the active name node again? Will the other name node become active?
No,
Why?
because there is no more failover controller.
Okay, so what happens? Just make me understand from this flow. Okay, I haven't mentioned failover controller here. Let me just recreate this diagram with a failover controller and zookeeper. Okay, so these two are contacting the general nodes for the FS image, but there is another service called failover controller which is running on both of them. So somewhere here we have zookeeper, which is storing the state of current active name node. Okay, and on both of these we have ZKFC, or what we call failover controller. Okay, so both of them are talking to the zookeeper using this service ZKFC failover controller. Now we have stopped the active name node and we have also stopped these two services. Okay, so now let's say, okay, let me just stop the active name node again. So this will explain you the concept of fencing as well as the concept of split brain scenario. Okay, so the active one is now stopped. Do you think this will become active? So you said no, right? Now I need to understand from this diagram why no.
Uh, because like not zookeeper, sorry, failover controller like incorporate with journal nodes, right?
Hmm. No, it not in
So for
contacts with zookeeper only. Journal node will contact
uh,
with the name nodes. Okay, now tell me. Hmm.
for that probably like the FS image cannot be produced for the downtime of name node. I'm not sure though.
Okay, let me explain. You were like right on the track, but FS image concept will not come into picture of the active and the standby one right now. It will be a consequence of the active one not coming up. That FS image won't be created out of the checkpointing and stuff. Okay, so when the zookeeper goes down, now there is no connection with the zookeeper. Sorry, when the ZKFC goes down, there is no connection with the zookeeper. So the standby name node will not know that it has to become active now. The standby one, it will not know that it has to become the active. Even though the other one is showing not running, this has not changed the state to the active name node. Okay, because it wasn't able to contact the zookeeper to understand. So let's say when this stopped, this name node even also didn't contacted the zookeeper to change the state of the current active to the other name node. So zookeeper also has an older information, and same is the case with these two name nodes because they were not anymore able to contact because their zookeeper failover controller was down. So this will be the complete explanation to this. Now, just because somebody talked about fencing, let me explain what happens when the fencing is there. It is the concept of preventing a name node to write the edits on shared location of journal nodes. Okay, so what happens is generally this is done by the active name node. The active name, whichever one is an active name node, this has the responsibility to write the current edits file to the journal node. Okay, so the name node which is active, that actually has the current information whatever is there on the cluster. So if any more edits or things are done, this is the file which is creating this is the service with the active name node will actually be creating the FS image and the current edits file. And the current edits file, this name node has the responsibility to write it on the journal node also. But since we are also saying that the name node which is standby, that can also replace that information right? As soon as the active goes down, the other one will become active, and that's why it should have the current FS image. But this name node should not be writing the edits log to the journal node because it's standby. The current edit are not there with the standby name nodes. They are basically with the active name node. This is where the fencing concept comes into picture, where the active name node fences or prohibits the standby name node to write any edits information to the journal nodes. Okay, and this is what is responsible. So let's say if both of them become standby somehow, which will happen, I think. So what can happen now is that since we have stopped both the failover controllers, and now if we start the name node, two scenarios can happen. One is it still has the older state wherein it was active. So even if I start this, it will also become active. The other scenario might happen is it come back in the standby state only, which will be the split brain scenario. So let's just try to start it. Right now, I think it will come back in the active state only. Because somewhere it might have an older information that it's still an active name node. Okay, let's wait for it to, it's trying to connect to failover controller. That's why it's appearing not running. Yeah. Do you see this? So both of them now comes in the standby state, and this is what is because of the split brain scenario that happened here. And how does it is like why is it having a split brain? Because now both of them think they are standby. Okay, so ultimately none of them will be creating the current edits file, and none of them will be writing to the journal node because both of them are actually considering them as a standby. None of them is active currently, and none of them is acting as an active. The only problem here, now there was nothing, the scenario that I discussed with the split brain was that let's say, you have less number of journal nodes or less number of zookeeper, but since the name nodes were not able to contact to the zookeeper, both of them thinks that they are standby, and this is where none of them is able to write to the journal nodes. Okay, so this is what is very important to understand, that failover controller, it is majorly responsible to take care the state of the current active name node. So this service should always be active or running if you want to transition correctly the two name nodes, and if you want to have at least one active name node. Okay. Now, as soon as I restart this, now also, so the question which I think Tasnimul asked, how would you deal with fencing in such a case, right? It's already fenced. When you have both the name nodes appearing standby, both of them cannot write to the general node. So it's like a situation wherein you are already fenced and you are not allowed to write. These are a pretty high advanced topic, but to understand it might take some time for you guys. But just for the understanding right now, you must understand what each of these services is doing. So ZKFC, it take cares of the active state. The general node take care of the common location where edits are present. And the concept of fencing with Tansimul was asking about, it's basically your active name node should only write the current edits to the general node, and that's where it fences or prohibits the other name node to write the edits. And the split brain scenario is wherein two different services within the cluster thinks that both of them are either active or standby. Just as a high level understanding. So just try to read more about this for your understanding, and if anything you can also ask me. Okay. So now we have started the failover controller. Let's see if it automatically contacts the zookeeper and change these states or not. If not, probably we'll have to restart one of the. No. Now you can see the second one becomes active. Okay. So two things I want you to guys to study more about. One is again split brain scenarios in Hadoop. Other is leader follower election in Zookeeper, and I think it happens in general nodes also. Check that. Yeah, I think it happens with Zookeeper only. Yeah. So read about something which I was talking about as an election scenarios, the leader follower election scenario in Zookeeper and split brain, and try to do this experiment yourself, and while you're doing that, also try to check in the logs of each of these name nodes. You can find the logs here, where log Hadoop HDFS here. Okay, just try to see what is being printed. You can use the tail command for that. So when you're starting it, when you're stopping it, just try to tail. So parallelly, you can run both of the name nodes, and you can run this tail command. And whenever you stop or start anything, just try to see what is being printed in the logs. Okay, but yeah, this is a little advanced concepts. The failover, the fencing stuff, uh, and even this leader follower. That's why I'm leaving it somewhere so that you can study it on your own pace. It might take a little more time to give you more intricacies about these concepts. But yes, if you all read about them, we can probably have a discussion and get our concepts more better onto these. Okay, so this was about HA. Now let's okay, we have already talked, I think, about the checkpointing and its scenarios. I think we discussed that, right? Yeah, yeah. The four scenarios wherein the checkpointing occurs. I hope everybody is clear with the checkpointing, what exactly that is. Okay, so checkpointing, just for a quick recap, it's combining the FS image and the edits file. And the scenarios in which checkpointing occurs is either after a particular time, which is 1 hour, or after a particular changes in the transaction, which is 1 million by default, or if we restart HDFS service of, let's say we restart name node, and also we can manually run save namespace to do the checkpointing. Okay, now let's quickly talk about safe mode. This is the last, like not last I can say, but yes, uh, one of the important topics that relates with the name node. This we have already done. Okay, safe mode. Anyone has some idea what exactly is, if you have read about when you were reading about HDFS? Okay, okay. So safe mode, as the name suggests, it's basically a maintenance mode, or you can say it's a read-only mode of the name nodes. Okay, so what happens is, as soon as you restart the name node, it first enter the safe mode. Okay, so mostly when we restart, or let's say we start the name node, the name node, first of all, whenever let's say somebody is newly joined to an organization, okay, and he has joined as the manager of that organization. So what is the first thing the manager does? It introduces himself to the whole team, right? And then after that, it gets the information about what the work is being done currently in the organization. And once he has all of this information, then only he can start working on his task and his job, right? Similar is the case here. So let's say whenever the name node is started, name node is basically the manager in this situation. So when it started, it first of all gathers all the cluster information. It loads the file system state. Basically, it's loading the older FS image, and if the older FS there's also an edits present, it might also initiate the checkpointing. That's why I told you whenever you restart the cluster or the name node, there is also a checkpointing. So that checkpointing is basically taking place because now the name node should have complete information, and that can only be done when the checkpointing has been done and FS image is newly created. So immediately when you restart, a safe mode state is entered, wherein the name node gathers all the cluster information, how many data nodes are there, which are reporting fine, and it also loads the file system state, which is FS image. And once it loads it, and once it knows which all data nodes are up, okay, so let me just be specific. Okay, and then it also waits for the data nodes to report the block information. Now what happens is, how our data nodes and name node are in like sync with each other, because each data node is actually sending two kind of informations. One is called the heartbeat. The other information is called block report. Heartbeat, as the name suggests, this will be sent, I think, after each. Let me check the heartbeat interval. I think it's 3 seconds. Let me just confirm that once. Yeah. So heartbeat interval by default it's 3 seconds, and there is also something called a stale data node time interval, which is 30 seconds. I'll come to that. So by default, every 3 seconds, a name node will tell the name, a data node will tell the name node that it is active and running. But let's say the data node goes down. But how will name node know that the data node has gone down? So it will wait for another 30 seconds. The name node will wait for another 30 seconds until it doesn't receive a heartbeat within those 30 seconds. Then it will declare that that particular data node is actually down. Okay. The other information which the data node sends is called a block report. Block report basically contains information that which data that all what all blocks does a data node store. Okay, so these three kind of information will be sent separately by these two kind of information will be sent separately by each data node to the name node, which is ultimately uh, helping the name node understand the current state of the cluster. Okay, so what happens in safe mode? Again, when the cluster is started and it enters the safe mode, the name node enters the safe mode, it will check first of all the heartbeats and understand which of the data nodes are active, stopped, or decommissioned. Then it will load the file system and understand what was the previous state. Then it will wait for the data nodes to report the block information so that the name node has the current understanding of which blocks are already there, which blocks need to be replicated, all that information. We haven't come to replication yet, so I will explain that a little bit in a little while. But you can understand that each data node will be sending the block report or the block information. Now, whenever all of this is happening, there is no write allowed in the cluster when it's in safe mode. And that's the reason we also called safe mode as a read only mode.
Sahil, I do have one more question.
Mhm.
So in our local computer, like we can log into like safe mode. So in Hadoop, can we like manually log into the safe mode?
In your local computer, I don't understand how,
I
like,
mean, like
mhm.
in our regular computer or like a laptop, we can like before it starts, we can log into like pressing F1, F2, we can log into the safe mode, right?
No, that's not a safe mode. Okay, so you are saying, so just when we restarted, if you like, you want to explore the boot options, right? So boot
Correct.
options basically wherein you are changing the, I think, if you want to reset your computer, if you want to do some other boot level operations, then you press escape or F1 just at the time of restart, right? That's something else. So when you restart your laptop, you can you can say like, so when you restart it, immediately the laptop gathers the information it had stored earlier in the disk. So that's also kind of a safe mode operation only, but I don't think you cannot write in that scenario. You are still able to write stuff immediately when you have restarted, but that's not the case with a cluster environment.
Okay,
The
okay.
clustering
Just make it.
environment, yeah, because there is not, so a single server, you know let's say a single data node is being restarted, it's not very difficult to gather information. It will take milliseconds or even second, let's say 1 or 2 seconds only to gather that information about a single server. But when it's about cluster of servers, hundred of servers, and that all has to report to a single active name node, that will take some time. And that is the reason why they have created the safe mode. Because let's say if there are hundreds of data nodes, so all of them will take some time to report a heartbeat and a block report to the name node. And in that particular time, I don't want anybody to write any new information within the cluster. Okay. So that's the reason they have kept a scenario called a safe mode, wherein as soon as you restart, the name node will not allow any writes, any new more write to the cluster until and unless the name node is completely sure about the current state of the cluster. Okay, and all of these steps that I discussed, these are basically how the name node becomes sure about the complete information. Okay, so once name node gather this information, and it will take another 30 seconds after that. So the name node will exit the safe mode automatically after it has loaded the complete file system image and every block of data which is expected to be stored in the cluster is now available, or at least the name node has the information about it. Okay, plus 30 more seconds. So after, I think it will take another 30 more seconds once all of this information has been gathered, and then after the name node will leave the safe mode. Okay, this is an automatic operation when you restart the name node. But there is also a manual way. There's also a manual way of changing the safe mode using a command which is HDFS DFS admin hyphen safe mode. There are three options: get, enter, and leave. Okay, let me just show you quickly. But mostly it's not recommended to run manual command. It's always recommended that the name node should automatically leave the safe mode instead. So if I run get, you can see both of them are off, right? Now I can also make it on if I just type enter manually. Now both of them have entered the safe mode. Let's try to read something. Sorry, temp. Okay. I think even if we are in safe mode, so what is happening now? As soon as I've turned this safe mode is on, right? All of these things are happening. Data node will give, name node will load the FS image. It will checkpoint the system. Okay, so you can also enter it as a scenario. If you manually enter the safe mode, so if you manually enter the safe mode, then also the checkpointing will take place. Okay, yeah, so I was showing you that I can read. So let's try to read this file in the temp location. Read basically means I want to get this file. Yeah, I was able to get it. Right, so read is working fine. Let me check if it's still in safe mode. So if you manually enter a safe mode, right, we cannot automatically leave. We will have to manually leave also. If we manually enter the safe mode, we cannot leave automatically. We will have to leave manually only. Okay, so before manually leaving, let's just try to get it again, just to show you. Safe mode get, it's still in safe mode. Now let's try to write a file. Okay, I'll make a file named sahil.txt. a 0 KB file. Now let's try to put it in temp location. What does it say? Cannot create file. Name node is in safe mode. So you can read files, but you cannot write a file when you are in a safe mode. And now to leave safe mode, how will we leave? And just use the leave option. Now you can write. Okay. So this is also an important concept called safe mode. You can think of it as a, if you want to remember it, I remember it as a maintenance mode or a restart mode or a read-only mode, because when you are in maintenance, no one is allowed to do or change anything, but yes, you can still gather or get the information. Okay, I am also sharing a link from where you can get somewhat more information about this. So HDFS, I think it's very important concept, not just as a storage layer, but if you are targeting interviews and companies, they generally tend to ask a lot of questions from HDFS, and questions will be around safe mode, you know, checkpointing or HA. So these kind of scenarios will be asked, or let's say, the kind of scenario that I told to you, those might be asked from you. So give a little more reading to HDFS concepts and try to practice it along so that you have become more clear about each concept. Okay, so we are done with all the concepts of name node. Okay, few of the commands I've discussed about reading and writing files. There are few more commands how you can read and write. Okay, so up till now we were using command HDFS DFS hyphen get location of file in HDFS, and the destination can be either a location in HDFS or it can be a location on the local server. But there is another command called DFS hyphen copy to local. So in this command, your source or the location from in the HDFS from where you want to copy a file, you can copy it only to the local server, not in another location in HDFS. Okay, so there is slight difference, but ultimately both of them can be used to copy or to get a file from HDFS to your local server. Okay, similar is the case for so this was about read or get. Similar is about write or put command. So basically we again have two more commands. One is HDFS, DFS hyphen put. Then will be your file, and that file can be a location in the local server or HDFS. Or if you just want to copy from local, you can say copy from local. This will only be okay. The other one is a location within the HDFS. Okay, so when you're saying copy from local, it's always a file on your local server which you are copying to the HDFS. Okay, just try out these two commands. I've been using put and get mostly, but try out these two commands also. They will work similarly. But what I want you to test out is try to get a file from a location in HDFS to another location in HDFS as well. So up till now what we are doing is we are just putting a file from local location to HDFS, right? So let me just show you once a difference between these two commands, put and copy from local. So if I do ls over 10, let's say this is a file. Now I want to let's also ls over another location in HDFS called user. Okay, so these are the like location within the user. Um, let's try to, or let's create a directory in HDFS temp slash, let's call this directory another. Okay, now I want to put this file which is in temp test to temp another. How can I do that? So I can do something like dfs hyphen put hdfs colon double slash hadoop 9 slash temp test, and I want to put it into the HDFS. And you can observe now I'm actually referring the complete path. This is because I want to put a file from a location in HDFS to another location in HDFS. If I wouldn't specify this thing, no, it will automatically try to pick a location on the local server. That's why I need to specify that it's actually in the HDFS. I think it's B9 instead of 9. B9, let's try with B9. Okay, I think get is working here. Let's check into this. Okay, I'll explain you this difference. I'm actually like missing out on something probably. But yeah,
Wait,
ultimately, yes, who's this?
sorry. Oh, this is Tazma. Where did you get the path of Hadoop B9?
Yeah, this is the name service.
Oh, I see. Okay.
We talked about it, right, just now.
Yeah. I see. I forgot. Sorry.
If you miss out on it, you can also get it from here. Just type name service in the configuration. You will find it. Okay. Yeah, a little. I have have some confusion why exactly it's not picking from HDFS. Let me just get over this concept again. You also try it out at your end. Okay. So try to understand the difference between get and copy to local. Similarly between put and copy from local. Okay. Uh, so another very important concept which is left out is of under replicated blocks, or what we call as a replication. Okay, so this is okay. Every block of data, I hope everyone remembers, has a size of 128 megabyte by default, right? And okay, let's say there is a situation wherein I only have one data node, which is currently our situation right now. We only have a single data node and we stop it. Okay, so my data node is stopped. Will I be able to read any data in this situation?
No.
No, right? So why no? No, because all my data and all my blocks were present on a single data node. Okay, now how to prevent a situation like this? How to prevent a situation wherein uh, you can you lost you cannot retrieve your data when the data node is down. Definitely you would want to add more data nodes, right? Now how to make sure that each data node at least have some information about each data block? That's where replication will come into force. Okay, so concept of replication, it says each block of data will and must have more similar copies which can be stored on separate data nodes, so that in a situation where one or some of the data nodes are down, we can still retrieve the block of data from the other data node which might still be running. Okay, so what happens is, by default there is a concept called replication, wherein each block will have some copies created, and those copies will be stored on separate data nodes. Okay, and as soon as one of the data nodes go down, or let's say even some of the data nodes goes down, you can still retrieve that copy from other node. Now by default, the number of copies each block has is 3. It's also called as a replication factor. Okay, so by default, each block will have 3 replicas, and that's the reason we should at least have 3 data nodes, because each block will be stored on each copy of the block must be stored on a separate data node, because in an event of failure of one of the data nodes, you can still retrieve the copy from the other data node. And that is the reason we had under replicated blocks. Under replicated, what do you understand by this? That the required number of replication was not fulfilled. Under replicated blocks, when we had a single data node in the cluster. Okay, so you can see this error. It says Cloudra suggests at least 3 data nodes. Why was this happening? Okay, let me just start this one first. This was happening because we had only one data node, but we require at least 3 data nodes within the cluster. Even if you check on the status, you would see this error under replicated blocks. Because it expected to have 3 data nodes so that it can copy 2 more copies of each block onto the other 2 data nodes. So what we'll do now is, we only have one data node, we will add 2 more. So I'll click on this add role instances. Select data node, custom. The 2 nodes that I had recently added, I will add the data node roles on these 2. Okay, continue. This is the location where data node stores data. That is added. Now I will just start these 2. And as soon as I start, what will happen is name node will start replicating or creating copy of each block which was earlier on only one data node, and start copying those blocks to the 2 more data nodes that I just now added. Okay, you can check that under replicated block information from some admin commands also. One of the widely used admin command is HDFS DFS admin. Okay, so any admin command will always start with DFS admin. If you want to check all the admin commands available, you can type help. Okay, so we have all these commands available. The command that I am interested in right now is HDFS DFS admin -report. This will give me a report of the complete cluster report. Okay, so you can see now it is reporting 3 blocks. There are only 248 under replicated blocks now left, because the other data nodes are also now copying the replicate blocks, and now you can see there is no replicate. Okay, there is still 148. So slowly and steadily it's copying the blocks from the only single data node to the other 2 data nodes. Okay, so now my cluster is complete. The HDFS part is totally complete. I have HA, I have 3 data nodes. Okay, this is an ideal situation for storing your production level data without worrying that a situation may come where either you are in a situation where you lose data, or you are in a situation where you cannot read data if any of the server is down. Now, as and when your data increase, your data grows, basically you can add few more data nodes to increase the. So if I just do head 15 or print only the first 15 line, head 15 means printing only the first 15 lines. So right now my cluster capacity is 30 GB, out of which 28 GB is left. Okay, if you want to have more capacity, you can keep on adding more data nodes. Okay, this is how HDFS works. Yeah, so you can explore few more admin commands. I think we have explored report command, safe mode, save namespace. Okay, there is something called as quotas also available, which we will refer in a later stage. And okay, one very meta save is another command to create, I think, an FS image. Uh, Another command which is very important, which is not an admin command basically. So we talked about DFS, and then we talked about the FS image and the edits file, right? Now if you just uh, want to read this file, you cannot read it out like this. This is all binary information. You can see all of this is binary information, so this file is not human readable. The FS image and the edits, even the edits, these are not human readable just by doing a cat over these files. But what if you want to read the file system information of the name node? To read and analyze the file system image of the name node, we can use a command HDFS FSCK, and there are a few options with it. Let me just show you a simple FSCK. FSCK stands for file system check. Okay, so the command is HDFS FSCK. There are few more options. Let me just type help. Okay, so if you want to get information, just the information, what you can do is HDFS FSCK. Let's say I want to get all the information about the complete slash, or which is the complete HDFS. So I can say slash, then which is basically a path. Then I want to get information about all files, all the blocks associated with each file, and all the locations where these files are situated. So by this command I can get that information. Let me show you. So basically it's a check. So ultimately it will tell me whether my file system is healthy or not, and how many files I have. So I have around 749 files. And also let's say about each file. So let's say if this is a file, it is telling me the block, how many blocks this file has. So this file right now has only one block, because I think the size, this is the size. This size is not 128 or greater than 128 megabytes, right? Which is my default block size. So only one block is created for this file, and it also tells me the data nodes on which this file is present. The block is present. So now you can see you have three data nodes: 176, 69, and 72, because this single block has three or two more replicas. So there are in all three live replicas, right? And the three live replicas are present on three separate data nodes. So you can get the complete state of the file system using this command of files, blocks, and locations. But yes, you have many more commands with FSCK, sub commands I would say. Okay, so you can explore more of them. There is a concept of corrupted files also, and a concept of rack. I will explain probably tomorrow when we discuss. So we are only left with two, three more topics in HDFS. One is yeah, corrupt, missing, and under replicated blocks. I think under replicated I have already explained. I'll explain the concept of corrupt and missing blocks. Then we are left with quotas, which is basically file and space quota. Yeah, I think these two are the major ones which are left. Rest all we have already covered up. Okay, I think we can uh, stop discussion at this point. Tomorrow, when we complete these things, right, we will move ahead and discuss about the other service, which is yarn. Yeah. Okay. Any questions, guys? Anyone? And I hope everybody is stopping their instances right after they are done. Okay, any question before I stop my instance? Anything you want me to explain again? Okay, let me just upload. Okay, if you don't have any questions,